Okay, unit 1, gas power cycles. Unit 1, gas power cycle. What is meant by cycle? What is meant by cycle? A repeated series of process takes place in a certain order where initial and final states are states are same, identical. Really? Clear? I explained what is meant by state and explain panna. What is meant by change of state appo explain panna. Amalia, change of state panna, appo change of path explain panna. Amrika, remember change of path I explained. Then I explain what is meant by process. Then I explain what is meant by cycle. You won't explain panna. State is a condition of the system. I explained. Now we have chalk. Right? We have chalk. If you want to give some specification for this chalk, what will you give? This is cylindrical shape, of diameter this much, of height this much, it has pressure this much, it has temperature this much. If you specify all the properties, temperature 30 degree, pressure 1 bar, diameter 10 mm, if you specify everything, that is called state of the system. System is called chalk piece. That is a state. Change of state means if temperature rises 1 degree, temperature rises 1 degree, that is change of state. Got it? That is change of state. If that state is completely specified, that path is there. Now how it is changed from 30 degree to 31 degree. If you see that path, that is called change of path. That is called change of path. If you specify that path completely, really, for example, I am here, okay? I am here. I am moving from here to here. This is called change of state, change of path. If you specify this path completely, how I moved from here to here, that is called process. State 1, state 2. State 1, state 2. If you specify this 2 completely, that is called process. Then again from 2 to 3, I am moving here. That is process 1. This is process 2. Now from here to here, I am reaching here. This is process 3. So process 1, process 2, process 3. Where I started? Here only. Where ended up? Here only. Where initial states and final states are identical. This is called what? Cycle. This is called cycle. So now we are going to see cycles. Now we are going to look up cycles. Clear? Where a series of operations takes place, where n number of cycles will repeatedly takes place. So we are going to see about cycles. Then why we call power cycles? Why do we call power cycles? Yes, the output is a power. The output is a power. It is a power producing cycle. It is a power producing cycle. That's why we call power cycle. Why we call it as a gas? Using gas from starting to ending. That's why we call gas power cycles. What about another power cycle we discussed? Vapor power cycle, steam power cycle, Rankine cycle. Yeah, those are the power cycle only. But there we don't use completely gas. 2 type of medium. Liquid will be there, gas will be there. Half of the cycle liquid, half of the cycle gas. First we need to know few things. Before studying this one, we need to have some assumption because these are the ideal cycles. First one you write down air standard cycle. Using working medium as air for complete cycle is called air standard cycle. Very simple. Next one, air standard efficiency. Calculating efficiency using air as a working medium is called air standard efficiency. Assumptions, very important. Okay, repeatedly in 2 marks you will ask what is meant by air standard efficiency. What is assumptions used in air standard cycles? Repeatedly they ask this. First one, the working medium is a ideal gas. What is ideal gas? Ideal gas is another. Air the ideal gas. Okay. The working medium is a ideal gas and it should obey ideal gas equation. The working medium is a ideal gas and it should obey ideal gas equation. Very, very important. Very, very important. What is the ideal gas equation? PV is equal to MRT. Repeatedly we have to use that equation. Wherever you need to calculate mass, temperature, pressure, volume for any state, we have to use PV is equal to MRT because the air is obeying ideal gas equation for each state without any fails. Here, second one. All process takes place. All process takes place are reversible. Or reverse. What is my reversible? What is reversible? Why we call it reversible? There is no any losses, right? Friction losses, any loss. There is no. That's why we call reversible. Ideal one. All processes are reversible and adiabatic. All processes are reversible and adiabatic. What is in by adiabatic? Rapid process. What will be the constant? Q is a constant. There is no heat transfer from the system to the surrounding and surrounding to the system. That's why we call adiabatic process. Right? Good. Next one. No chemical reaction takes place. Heat addition. Heat addition. Next point. Next point. Heat addition is considered as constant volume. Heat addition is considered as constant volume or constant pressure. Heat addition. Specific heat capacity. You heard about right? Specific heat capacity. Heat capacity we have seen, right? Big one complete hour we have seen. Wow, heat capacity plays a major role. Do you remember or not? To rise 1 degree Celsius. Do you remember how much energy is required? Do you remember? We have discussed the third or fourth class. Clear? So, specific heat capacity will be constant throughout the process. Specific heat capacity will be constant throughout the process. These are the assumptions we will take place. Okay.